volume of prisms. Okay. The volume of an object is defined as being the amount of space a three-dimensional object takes up. You know what volume is? It's how much water you could pour into the object if you then poured that water out into a nicer shaped container like a measuring cup. That's volume. A prism is any three-dimensional object with at least one pair of parallel sides. We're going to be talking about prisms, pyramids, and cones. So a prism has to have somewhere two sides that are parallel. It says, find the prisms in the following diagrams. For each prism, shade in the base and state its name, rectangle, circle, triangle, etc., and its formula. We'll get to the formula in a second. The first shape, prism or not? Does it have a set of parallel sides? Yeah, which ones? Top and bottom. This would be a triangular prism where that and that are parallel. What about second shape? Prism? No, that's going to be called a pyramid. What about third shape? Yep. What's the base shape? So lots of parallel sides. I'll shade in this one, and this would be a rectangular prism. What about shape number 4? Nope. What about shape number 5? Yeah, although you know what? We need to add that little... we call this a cylinder, but it's also called a circular prism, but this one's going to have a special name. We're going to call this a cylinder. A cylinder. The next row. Yep. This is a hexagonal prism. Hexagon. What if there was 8 sides? Octagonal prism. What about this one here? Nope. What's it called, by the way, this shape? Sphere. What about this one here? Yeah, it's got a parallel side there and there. This is a, if you laid it flat, triangular prism. Spell the word prism right, Mr. Dueck. So a prism, 2 sets of parallel sides, at least, maybe more. And every single prism has the same volume formula. They're all the area of the base times its height. So you need to imagine Simi laying it flat so that the 2 parallel sides are on the bottom and on the top, and it's the area of the base times the height. In other words, the area of this here, the area of that triangle times the height. The area of the rectangle times how high it is. The area of the circle times how high it is. Flip this guy on end, the area of the hexagon times how high it is. This is every volume of a prism. Really what that means, Greg, is you're going to need to know or figure out from the sheet what the area of the bases are. So the following table gives the formula for each prism that we will use. This is also on your formula sheet. What's the name of the base of the first one? Rectangle. What is the area of the base? What's the area of a rectangle? Now, I know that is actually on your formula sheet, but this is one that's worth having, I think, up here. What is the area of a rectangle? Then go look it up on your formula. Go find it. Length times width. And since the volume is the area of the base times the height, I think the volume, which is also somewhere on your formula sheet, is going to be LWH. I think on one page you have areas and perimeters, and on the back page you have volumes, yes?
Yes.
But that's where the equation comes from. Want the volume of a rectangular prism? It's length times width times height. It's area of the base times the height. What's the base of a triangular prism? Why, that is going to be triangle. What's the area of a triangle? Anyone? It's on your sheet. Find it.
EH/2.
Base times height divided by 2. Now, on your sheet, look up, look up, look up. That's the base and that's the height, but we also have a height here. So instead of base times height divided by 2, I'm going to say here it's length times width divided by 2 based on that picture there. Which means the volume is going to be length times width divided by 2 times height. Naomi, do you notice that volume equation is the same as the one above it, except divided by 2? What we're really saying is that triangular prism, it's half a box. Take a box, cut it in half. That's what you got. Cylinder, what shape is the base?
Circle.
What's the area of a circle? Go find it, folks. Shouldn't be any hesitation. It's on your sheet. You need to know where it is on your sheet. It's on the front page, with the same page that has the ruler. Pi r squared. Where r is the radius. That means the volume is going to be, Amber, pi r squared h, area of the base times the height. Now, you will notice they do a picture of the cylinder. They do have that volume equation on there. Oh, no, they don't quite. It just says area of the base times height. Area of the base times height. So you have to generalize. Oh, but they gave you the areas of the bases on the previous page. Example 2 says, find the volume of the following. Be sure to write the formula. Step 1, identify the shape. What is the shape of shape A? Cylinder? So volume is going to be area of the base times the height. What shape? Now, I'm not going to redraw it. I'm just going to imagine it flipped up. Is that okay, folks? What shape is the base? So it's going to be pi r squared h. Pi, careful, what's the radius? Not 18.
9.
Or is that a German saying no? 9. Yeah, 9 squared times 21. This is your chance on your calculator, which all of you have out, to find out where your pi button is, if you haven't already. 3.14 is not acceptable. You may find that your answer doesn't match the answers in the multiple choice section of the provincial. You need to find where your pi button is. Usually it's somewhere around the divided by key, shift, or it's somewhere on the bottom row. So try typing that in, and if you can't find your pi button, now is the time to call me and I will come find it. So on my calculator, my pi button is in yellow right there. Yellow means hit the yellow button first. Yellow. Pi times 9 squared times 21, and I get a volume of 5343.8. 5343.8. I'll be with you in a second, Marcus. The units, millimeters cubed. Volume is measured in units cubed because you've gone length times width times height. You've multiplied 3 things together. That's why it's cubed. Now, if you didn't get that, let's look. Keep going. B, Oh, the volume is going to be the area of the base times the height. What shape is the base? Not careful. No. For a prism, you got to imagine the two parallel sides flipped so that one's on the bottom, one's on the top, right? Really, we should flip this like that. What shape is the base? Not a rectangle. What is it? It's a triangle. What's the area of a triangle?
Length times width.
On your formula sheet, it says, I think, base times height, but I've also got a height here. It's going to be, length times width over 2, or base times height divided by 2. I just don't like two heights. Can you see what the numbers are going to be? It's going to be what times what times what divided by 2. See the triangle? What's the length of the triangle?
8.
That's also the base of the triangle. What's the height of the triangle? 6. And then if you flip this on its end, laying it flat, what would the height of the shape be? 30. Are you using the 10 at all? Nope. Just there to distract you. Yep.
But the 30 is in centimeters.
Ah.
Millimeters.
Ooh. So what's 30 centimeters in meters, Jordan? Sorry? 0.3. Good catch. So it's going to be 8 times 6 times 0.3 divided by 2. On the provincial, I don't think they'll try and trip you up with units in a cheap way like that, but just in case, we did one. 8 times 6 is 48, divided by 2 is 24, times 0.3 is the answer, 7.2? Yeah? That's pretty good. Units, meters cubed. C. This is also a triangular prism. Again, you need to imagine it, Sam, flipped up with the triangle on the top and on the bottom. So what's the volume going to be? It's going to be area of the base times the height. This is what it says on your sheet, yes? Is that correct? Okay. So we can also write that as our equation. What's the area of the base? What shape is the base? Triangle. That's going to be what times what divided by 2? More specific in this question. Numbers. 5.1 times 2.4, and then times the actual height of the object itself. Did we use the 4.5s at all? Just there to distract you. Actually, you would need those if you wanted to find the surface area, which is tomorrow's, Wednesday's lesson. Nope, Wednesday's your test. Monday's lesson. .1 times 2.4, the decimal didn't show up in my work, there we go, times 6.3 divided by 2, 38.556. I'll go 38.6. Is that right? Units. Centimeters cubed. Volume is cubed. You know which one is squared? Area. You know how you can remember that? Square area. Area, square area. That's how I've remembered it since I was in grade 8. Number 3 says, find the volume of the cylinder in example 2 in cubic inches. So we have this in cubic, we have this in cubic millimeters. So now we need to do a conversion. We're going to go 5,343.8 millimeters cubed. We're going to start out writing down what they gave us. Do I have a way to go from millimeters to inches? I can go from millimeters to what? Sorry?
No, it's 2A.
2A, right? Not 2B, it's the cylinder. 2B or not 2B, that's not the question. Sorry? Go to centimeters and then to inches? Okay. How can I go to centimeters? Millimeters on the bottom, centimeters on the top, except it's millimeters cubed and it's centimeters cubed. Oh, and you noticed on your sheet it says 1 centimeter is 10 millimeters. Oh, but we said if it's cubed, it's got to be cubed and cubed. That's how you deal with it for volume. What if it was area squared? You wouldn't go cubed and cubed, you'd go area squared. By the way, the 1 cubed on the top, is that going to make a difference? Is 1 times 1 times? But I wrote that just so that you know, Simi. We did, just in case it's ever not a 1 for a different weird conversion factor. You cube it, cube it. Now we are in cubic centimeters. What do we want to end up in? Cubed. Oh, by the way, find the volume in inches cubed. Thank you for fixing that for me. Good point, Darian. I want centimeters, I want inches, but cubed. Do I have a conversion factor for centimeters and inches? I hope I do.
Yes.
What? 1 equals 2.54. Oh, but cubed. So it's going to be 5343.8 times 1 times 1. Am I going to bother doing the times 1 times 1? Divided by 10 to the third and divided by 2.54 to the third. And I get 0.326 cubic inches. I hope. Right? Remembering where our exponent button is, all coming back to us. One more, then we're done this lesson. Moving on to the next one. I'll be giving you a little bit of homework from both. But you'll have all week to work on that because your main homework is going to be study. It says, find the volume of the following. What I've done is I've given you that shape, but I've cut a cylinder out of it. How could I, is that okay, Amy? How could I figure out, if I cut that cylinder out, how could I figure out the volume of that shape? I don't have a volume formula for a chair with a hole. Or do I? Any suggestions? You're saying I can break this up? In fact, I think what I would do is I would probably say, add a dotted line right there. Let me zoom in. And I would call this guy here volume 1. I would call this guy here volume 2. That's the box on the bottom. And I would call the cylinder, take a guess. So now that I've broken it up into small block, big block, and cylinder, can you tell me what I would do with those 3 volumes if I wanted to get the answer here?
Add 1, 2, and subtract 3.
Yes. Okay, my approach, Marcus, brilliant, is going to be 1 plus 2 minus 3. You know what? That's so profound. Let's write that down. It's going to be 1 plus 2 minus 3. I use Roman numerals because I was worried if I actually put numbers on there, I think they were lengths. You could have called it A, B, and C and used letters for that matter, X, Y, and Z. All right. What shape is shape 1? Rectangular prism. So that's going to be length times width times height for that shape. Yes? Plus. What shape is shape 2? It's also going to be length times width times height for that shape. Minus, which is what?
Pi r squared times height.
Pi r squared h. R squared, R2, battleship. C3, battleship. R squared, math. Hey, remember that joke? That's like from way back when. Got our approach? Okay. I'll change colors. Shape 1, length. How far is this line right here? Oops, now I just scribbled it out accidentally. Let's see. Marcus, how far from here to here?
15.
How far from here to here?
12.
How far from here to here?
3.
See it? That 12 is the same as this line right here because these are nice right angles. I agree. 3. Width, let's call this the width. Even though it's longer, the width doesn't always have to be shorter than the length. I just have to be consistent. So we'll call that line there the width. How long is this line here? 5? See it? Yep. Height, that's this line here. Or this line here. Or this line here. 4. Plus the big shape. Length. You know what, Mr. Dueck? Why don't you cleverly change colors to draw that one? Good call. Length. $15, I think. Times width. 5 times height. How'd you get the 9? Ah, there's the 13 is the whole side on the front, and that little chunk is a 4. 9. Minus pi, I can get that right. R. Don't forget the squared. H. Now H is going to be that length there. That length there. Ah, that's the 5, isn't it? Nice. Hey, took a bit of work, but Greg, can you see it? It's. By the way, the other way, you could have, if you wanted to, Greg, instead of breaking it into a small rectangle on top, you could have chopped it right down here and gone left-hand rectangle box, right-hand rectangle box, minus cylinder, equally as valid. But since Marcus suggested the top and the bottom, I went with that instead. Hey, go to your calculator. What do you get? Do you get 483.6725? 483.7? Units? That can't be centimeters. That's a length. Cubed. That's lesson 2. I'm going to assign some homework, but let me see how long I get through lesson 3 first. So keep that out. Continuing. Lesson 3, continuing on with volume. What's volume? How much water something would hold. And we've done then the volume of prisms, two parallel sides, area of the base. Oh, in fact, recall the volume of the prism is given by the formula area of base times height. And you've been clever enough to notice, Curtis, sometimes the base is actually vertical because the thing has been laid flat. We just imagined it flipped up, but we're not going to redraw it because I can't draw these things. We're going to look at three other figures. Two of these are based on prisms, cones, and pyramids. Can you figure out what I mean by a cone and a pyramid? What's the difference between a cone and a pyramid? A cone has what as a base? Circle. A pyramid can have a triangle as a base. You know what we call that? A triangular-based pyramid. Can have a rectangle as a base. You know what we call that? A rectangular-based pyramid. Can have a hexagon as a base. You know what we call that? Hexagonal-based pyramid. Can have whatever. Okay? Oh, and then the weird one is the sphere. By the way, can you guess that the sphere will have a pi in the formula somewhere? Because you can see there's like circles and stuff. Okay. What is the formula for a cone? What's the formula for a cylinder? Pi r squared h. It turns out that any cone is actually 1/3 of a cylinder. If you have a cylinder and a cone that have the same radius and the same height, you'll be able to pour the cone into the cylinder exactly 3 times, no more, no less. That's the relationship between cones and cylinders. It's 1/3 of a cylinder. What was the formula for the volume of a pyramid? Area of the base times the, formula of a prism was area of base times height. You know what? Not only is a cone 1/3 of its cylinder that it came from, a pyramid is 1/3 of its volume that it came from. The prism that it came from. If you have a pyramid and you have a prism and they have the same base and the same height, you can pour 3 of the pyramids exactly into the prism. It's kind of nice, kind of neat. Sphere, all bets are off. What's the volume of a sphere? It's on your formula sheet, I think. 4/3 pi r cubed. By the way, that cubed is not a coincidence because it's a volume and the units should be cubed. That one there was discovered, I believe, by Archimedes 2,000 years ago. Up until then, they were pretty sure that they knew it. He was the one who proved that that's the volume. And he did it by almost inventing calculus about 1,600 years before Isaac Newton invented it. He came very, very close. There's your nerd trivia. So you ready? It says, let's put these formulas, let's see. Square-based pyramid. It's a pyramid. And the volume is area of the base times the height. So I put an h there. What's the area of a square-based pyramid? Well, if it's length times width, but if it's a square base, the length and the width are the same length. You can actually probably go something like this. L squared times h. Yeah? That'd be quicker. If it's a rectangular-based pyramid, length times width times h divided by 3. What about a cone? By the way, it says RL. That L shouldn't be there. Can you scribble out that L, please? Pi r squared h over 3. Sphere, 4/3 pi r cubed. How do you type 4/3 into your calculator? 4 divided by 3. So, Let's try a few of these. It's on your formula sheet right in front of you, Darian. Just saying. So it says, find the volume of the following. Be sure to write formulas. A. It's a pyramid. What's your base on the pyramid? A square. So it's going to be L squared H divided by 3. It's going to be 15 squared height divided by 3. 15 squared is 225 divided by 3 is going to be 75 times 8 is going to be 700, maybe 150, 600? Don't quote me on that. Yes? Woo! Hey, that was pretty good. Units? Millimeters cubed, cubic millimeters. By the way, if you say millimeters cubed, that's fine. In the industry, they would say cubic millimeters or cubic centimeters or cubic inches. B. This cone, Greg, has been flipped sideways. So just imagine it laying flat without me redrawing it, please. Pi r squared h over 3. Equals pi times 5 squared times 13 over 3. Hey, Mr. Dueck, do that one in your head. Ooh, boy. With pi? Well, let's see. 25 times 13 is going to be 425 divided by 3. Oh, that's not going to work out evenly. You know what? I need a calculator for that one. Pi times 5 squared times 13 divided by 3. Did y'all get 340.3? Cubic meters. That's how much water that could hold. C. What shape? 4/3 pi r cubed. Ah, careful. What's the radius? Don't say 13. 6.5, because they gave you a diameter. That's about the only way they'll try and trick you. 4/3 times pi times 6.5 cubed. The only other thing they could do with this, Ashley, is they could give you the volume and say find the radius. You'd have to get the r by itself. What's the 4 doing to the r? Timesing, so how would you move it over? What's the opposite of timesing by 4? What's the 3 doing? Dividing, so how would you move it over? Times. What's the pi doing? Timesing, so how would you move it over? Oh, and then, remember, how would you get rid of a cubed? Cubed. Cube root. That would be, it'd be nasty. Amber on the provincial, that'd be nasty, but yeah, that would be fair game. And actually a nice application of cube root. Anyways, you want to practice typing that one in on your calculator, because some of you might have trouble with that 4/3 times pi times 6.5 cubed. You should get 1150.3. Cubic meters. Okay, let me come see your calculator. A cone, example 2. A cone-shaped funnel has a radius of 5, a height of 8. If the water is filled 2 centimeters from the top of the funnel, find the volume. Okay, we better draw a little bit on this lovely picture. I'm going to zoom in. When I do that, I lose some of the number. Well, okay, they told me that this was 5. Yes? And a height of what?
8.
How much are we filling this, though? Okay, it's going to be filled to this level here, which I think is going to be 6 centimeters, 2 centimeters below the top. By the way, these are those, you've seen those paper cups you can get sometimes, right? The cone-shaped ones. This is what you're talking about here. Okay, how much does it hold if you don't fill it to the top? Okay. Volume of a cone is what? Area of the base times the height divided by 3 times the height. Oh, area of the base, pi r squared h divided by 3. Pi times 5 squared times, 6 divided by 3. What'd you get? $157.1. And again, get in the habit of using your pi button. Don't you wimp out and use 3.14 because especially because we have so many exponents in here, you're going to find if you don't use the pi button, Garrett, your answer is going to be significantly off and you might not spot it on the multiple choice provincial. So, and it's actually less work to hit the pi button than it is to type 3.14, 159, 265, 3589, you know. What was it, 157.1? Units, cubic centimeters. By the way, what if instead of asking you to find that volume, don't write this down, what if I asked you to find that top section? How could I do that if I wanted just the top section? Alex said put the 2 instead of 6. Is he correct? Put the 8 instead of the 6? That would give me the whole thing. How does that give me that top section? Then subtract. Find the whole volume, subtract the chunk, and that's how you can get, I don't even know what you call it, a cone that's had the top chopped off. It's got a name, I can't remember what it's called. But yeah, pretend the whole cone is there, find that. Then subtract the chunk that's been chopped. This is the same as the chair with the hole in it that we did on the previous lesson. Really. That would be a good advanced provincial exam question as well. A lot of kids would go, I don't know what to... Hey, relax. Use your imagination. It's Sesame Street on steroids. Kind of like this. It says, find the following volume in cubic feet. How could I find the volume of this shape? What shape is it? A half a sphere, which has a fancy word, hemisphere. Oh, I've heard that word before. We live in the northern hemisphere. What you're saying is you live in the northern upper half of the earth, which is a sphere. What did you say, Kira? Say it again. Half a sphere. That gives us a hint on what we can do. Do the whole sphere and then half of it. How do you find half of something that's the same as dividing by? 2. You know what? This is going to be which is going to be 4/3 pi r cubed all over 2. Which is going to be 4/3 pi 6.2. They did give me a radius, not a diameter, I checked. Cubed all over 2. This would be if you're designing a bowl-shaped swimming pool. How much water can it hold? Granted, you don't often build swimming pools quite like that, but similar principle. So I'm going to treat it like a sphere and then divide my answer. 4/3 times pi times 6.2 cubed Gonna make it okay? Divided by 2. And I get almost exactly 500. 499.1 or 0.2? 0.2, round off properly. 499.2. Now that's cubic meters. It's not what they wanted. Ooh, do I have a conversion factor to go from meters to feet? I hope I do. I hope I do. I do? Okay, so now let's write down what we have. What units am I going to put on the bottom? What do I want to cancel out? What do I want on the top? Feet. Oh, but it's cubed. What's the conversion factor? Please tell me it's on there somewhere. 1 foot equals 0.3048. But Marcus, since it's meters cubed and feet cubed, what will I have to do with these conversion factors? Cubed. The 1 cubed won't make a difference. Oh, you know what? It's going to be 499.2 divided by 0.3048 cubed. It's going to be that number divided by 0.3048 to the third power. 17,630 cubic feet. I don't know how many decimal places we want to go to. What, you want to go to? Okay, 17627.4. Not too bad. That, by the way, that chain idea I taught you guys last lesson. Jordan, you want to make sure you watch the lesson. Hugely useful in Chemistry 11 and Physics 11 next year. If you wrap your brain around that, you're in good shape. B. Hey, what's the volume of that missile, bullet, silo, if you straighten it up on end? Hogwarts hat, sort of. What is that? I see 2 shapes. What's another word for and mathematically? You know what? We're going to go volume of a cone plus volume of a cylinder. Get an answer, and then we'll go to cubic feet. Is that okay, Sammy? Why don't you try this one on your own? I'll try it up here. Let's see if we end up in the same location. And then we're done both lessons. Woohoo! The radius is the same in each shape, but the height is different, yes? Is that okay, Sam? Because you look right now, you're like zoning completely out. You hear? Yeah? Don't let that back row that you chose to sit in drag you down there. Because there's some baggage, believe me. Can I type this all in one line? I think I can, because I have a good calculator. I listened to Mr. Dueck and got a half-decent one. Oh, divided by 2, Mr. Dueck? That's wrong. Divided by 3, it's a cylinder. Pi r squared h, check, plus pi r squared h over 3, check. See if you get what I got. And then if you got what I got, then try converting it. Am I right? Is it 51.1? No one else has got that yet? Let me double check. 70.7? Anybody? 56? Let me double check what I typed. Pi, yes? R squared, yes? Height, which is 6.7 for the cylinder, yes? And plus pi. R squared, height, divided by 3, right? Divided by 3. Make sure you divide it by 3, not by 2, by 3 for a cylinder.
51.1 now.
Woohoo! Did you divide by 2 accidentally? And I wrote 2 accidentally and caught myself because we just did that hemisphere question. The 2 was in my brain still. Divide by 2. No. Turns out pyramids are cylinders divided, or cones are cylinders divided by 3. Pyramids are prisms divided by 3. And then I did the conversion, and I got 1804.8. Is that okay? What's your homework? Nothing. Right. What's your homework? For lesson 3, I'm going to emphasize more of lesson 3 because to find the volumes of cones and pyramids, you kind of had to find the volume of prisms and cylinders anyhow. So I think you... number 1, A... C... E... G... 2, A... C... I think you can try 3 all. You know what? Actually, I'm going to nuke that. Change my mind. So 4A, yes? How could you do 4B? A box minus 2 spheres. Oh! I think I just suggested how. It's a box minus 2 spheres where, how far from here to here? 8. How long is this line here? How long is this line here? Think about it. Ah! So the big box is going to be length times width times 8 times 8 times 16 minus the 2 spheres. So that's okay. I think C is a hemisphere plus a cone. Ice cream, yeah, it's ice cream. So that's from assignment 3. And I think those answers probably should be good. From assignment 2, number 1, A, C, E, and G. H, I. And I suspect, sorry, A, C, E, G, I, no H. I suspect the stuff they're going to throw at you on the provincial are these ones where there's shapes cut out. Okay? So take a look at C. Can you tell me how you would approach question C, 3C? Big cylinder minus the small cylinder. Okay? I think the whole cylinder. By the way, what's the radius of the great big cylinder? Not 7 and not 2. What is it? 9. Okay? Minus the 7. And let's try B. So see if you can handle those as well. Okay? You got 15 minutes. You can work on this. You can work on your trig stuff. If you have any outstanding trig assignments, if you want to hand them in today, you can. I'm not going to type them in, though, if you want to hang on to them to study from. because your test is next class, that's fine as well.